All right, now we're on to our second example for motor efficiency. This one looks very similar to the last one. It says a 5 horsepower motor is only 85% efficient. How much power is required to be provided to the motor to operate? And again, we're giving our conversion factor of 1 horsepower equals 746 watts. So just like in the last video, anytime we work these motor efficiency problems, the first thing we want to do is write down the efficiency equation. And so we're just going to write down efficiency is equal to the output divided by the input. All right, and we're going to start working from there. Now we need to identify which of these variables we have. A 5 horsepower motor. Again, if we give you the horsepower of the motor, that means that is that motor's output. Okay, so this motor's output is 5 horsepower. So we can go ahead and write down output equals 5 horsepower. All right, and the next thing is this 5 horsepower motor is only 85% efficient. So we have the efficiency. So in this case, we can write down efficiency, or just abbreviate it EFF, and say that that is 85%. Or if you want to write it in decimal form so that you can do calculations with it, it's going to be 0.85. And the last thing is input, and it's asking how much power is required to be provided. That is the input power, but we don't know that. We're being asked to solve for it, and so we're just going to put a question mark right there. Now the next thing we do is we just plug everything in, and then we can do some rearranging later. So I'm going to plug the efficiency in on the left hand side, so that's 0.85 equals our output of 5 horsepower divided by our input. And we don't know what the input is, and so I'm just going to keep it as input. So here, we don't have input by itself. We want to have input by itself so we can, know what the value is. That's solving for it. So how am I going to get input by itself? Well, the easiest way, since this is a division problem, I can cancel out the division by multiplying, and I'm going to multiply by what's on the bottom, and that's going to put input out here, and then whatever I do to one side of the equation, I have to do to the other side of the equation just to keep it equal. Otherwise, it's not an equation. So times input. Now, on the right-hand side, because I'm multiplying, I'm dividing an input by an input. All right, so this is like saying input over 1, because anything divided by 1 is itself. And so this input is going to cancel out that input. And I'm left with 5 horsepower over 1, which is just 5 horsepower. And so after all the canceling, I have input times 0.85 equals 5 horsepower. Now, input again is not by itself, so I need to cancel out something. You need to move this 0.85 over to the other side. Since this is a multiplication problem, I need to divide by what I'm trying to cancel. So divide by 0.85. Again, this is an equation, so I need to do the same thing on both sides, 0.85. And on this side, this 0.85 and this 0.85 cancel. And so this will become input equals 5 horsepower divided by 0.85. Now we can punch this into our calculator and get an answer. So 5 divided by 0.85, and that's going to give us a value of 5.88. And it's important to remember that we have units of horsepower here. We don't need to lose those units, because that's what we're going to end up with over here. So this is going to be 5.85 horsepower. Right? Now, this is a legitimate answer. However, we're asked how much power is required to be provided to the motor to operate. We typically don't think of power in electrical terms using units of horsepower. We typically think about power in electrical terms using units of watts. And so we need to do this conversion from horsepower to watts. So let's kind of walk through that process. it's not all that difficult. So what we want to do is just start out with 5.88 horsepower. And this conversion factor shows me what two things are equal here. And if I divide two things that are equal, I get 1. And so, for instance, 1 horsepower divided by 746 watts equals 1, because these two things are equal. Well, if I multiply this by that, let me back up here, 746 watts, I can actually flip that over, and both of these are equal to 1, because 746 watts is equal to horsepower, and so it's dividing two things that are equal to each other, that's 1, and dividing two things that are equal to each other, that's 1. And so if I multiply this value by either of these, I haven't really changed it, because I'm simply multiplying times 1, and it's the same thing, right? Because anything multiplied by 1 is the same thing. So what I can do here is, when I want to do the conversion, it's very important, I want what I'm trying to get rid of on the bottom. And so in this case, I'm starting with horsepower, and so I want to use this factor right here, because horsepower is on the bottom. So let's watch what happens. This is no different than saying divided by 1, and then I'm going to multiply times 746 divided by 1 horsepower. And so what we see is that the horsepowers will cancel, and I'm left with watts, and I can clearly see that it's 5.88 times 746. And students sometimes get confused. Well, am I dividing by 746? Am I multiplying by 746? If you just work it out this way and just put whatever you're trying to get rid of on the bottom, you'll be just fine, and it'll cancel out, and it's clear to see that this is 5.88 times 746 watts. And so when we put that in the calculator, times 746, we get 4,388 watts. So that's 4,388 watts, or we could say that's 4.39 kilowatts. And that's going to be our input power. All right, so that is what the question is asking for right there. All right, so we just walk through. Remember, first thing we do is you write down the efficiency equation. We identify all the knowns, right? Write those out, and then we just plug those in to our equation. If our unknown is not by itself, then we need to isolate it and get our unknown by itself. In this case, it was input. Then we get our value, and then we got to make sure our value is in the units that the question is asking for. I didn't specifically ask for watts here, but if we're talking about how much electrical energy has to be provided to a motor, then we need to convert horsepower over to watts, because that's just a language that doesn't work in electricity, right? We want to be in terms of watts when we're talking power. And then we just did the conversion from horsepower to watts using this conversion factor up here. We just set it up where the unit we were trying to cancel was on the bottom, and that canceled the unit out. We were left with the unit that we wanted, which was watts. Did 5.88 times 746, gave us 4,388, and then we just put that in more easily understandable terms, which were 4.39 kilowatts. And that's it.